Hello. In this lesson, we're gonna talk about, we're gonna work on some homework guide. This week's homework, most of the questions, you already have some guide throughout the lectures, except for the first one. The first one, you can find those guide in the previous lessons, but their last 2 or 3 questions, I think I need to give you some guideline, okay? We talk about solving exponential equations. We talk about multiple methods, all right? One of them is, using function method, using, using the property of logarithm, using definition, or taking logarithm on both sides. And of course, for homework number 13, we got lots of such questions, okay? And of course, domain is often used. So let's look at some of these homework questions in this part. Okay, so homework guide. Okay, which is on exponential equations. Okay. The first few you can see those in the examples. For example, number 4, right? I will take it as an example number 4. That's my example number 1, which is number 4 in your homework. And here you have 1 plus e to the power of 4x plus 1, and that equals to 20, right? And of course, we're solving for x. Okay, so we certainly still have multiple methods, right? The first method, if you do the first method, second method, and so on and so forth, it still would work, except that before you apply the method, you may like to subtract 1 on both sides to do some simplification. So simplify this a little bit. Okay, and then you can look at the function method, right? You look at the graph, right? And you look at the graph, and this is the graph, right? And we make some adjustment to the graph. Say this is, let's try a few things. And over here, we got a 20, okay? So this curve actually, let me make some adjustment here. Something like that, okay? So this is the curve, You can see the curve never touched the x-axis as anticipated. Equals to 19, so you're gonna draw a horizontal line. Horizontal line would be 19. It crosses the curve once, right? So we anticipate there's one solution, but it's pretty difficult to guess what is the solution, right? So we know the point, and on this point, we know that if I would mark that point, right? If I would mark that point, I will mark the point as the x value, which I don't know what, right? And the output is 19. The output is 19. So it's approximately right here. So we kind of, we use similar method to graph and to identify how many solutions could there be. And of course, we don't know the x, right? So we don't know the horizontal, we don't know the input. So that you know that story, right? You know that story. And so we have to resort to algebraic method. But the graph tells us how many solutions to expect. Okay, so method 1, okay? We know that there's one solution. So there's one, the solution exists. it's a little bit hard to identify the precise value of the solution. Okay, so the second method, we can commonly we just take logarithm on both sides. Okay, we have talked about multiple methods before. And eventually the method we taking logarithm on both sides, you put in particular, natural logarithm is very commonly used. Okay, so as a result, we got 4x plus 1 equals to ln 19. And we're going to subtract 1 on both sides. So 4x equals to ln of 19, subtract 1. Okay, you need to be very careful. This is ln 19 is done first and then subtract by 1. Okay, and multiply both sides by a quarter. So x equals to 1/4 of natural log 19 minus 1. So that's the solution. So now if we put that dot on the curve, right? If we put that dot on the curve, so this solution, comma 19, and that will be the dot. Excuse me. That will be the dot we've been looking for. So solution is found. Okay. There are a couple of other questions of similar nature. And now let's look at number 6, okay? Actually, we're gonna do number 6 and then we're gonna do number 5. Okay, so that's gonna be example number 2. Okay, solve for x, right? Solve for x, the title hasn't changed. And the equation goes like this: 7 raised to the power of, 7 raised to the power of half x equals to 5 raised to the power of 1 minus x. I need to make the fonts just a little bit larger so you can see the negative, the negative sign. Okay. How do we solve the x here? Okay, how do we solve for the x here? Right? Well, the graphing of these two, okay, so first I'd like to give you the function perspective, If you look at these as two functions, right? One function is f of x equals to 7 to the power x over 2, right? And the second function is g of x. And this function is 5 raised to the power of 1 minus x. So if these two are equal, basically we're setting the output are the same. Okay, so solve for x basically is a question, say, for what input these two functions produce the same output. Okay, so identify all inputs x. Okay, inputs x such that the output, right, such that f of x, this output is the same as the g of x. Okay, same output. Okay, so that's the nature of the question. So if you want to look at how the curve will, work together, right? So this is 7 to the power of x over 2. Okay, So I'm making some adjustment to the picture. Because they're both positive. They're both positive. Okay, they're both positive on both sides because the range, right? The range are positive. And next, this F is a color of black. Okay, so black. And the G, I'm going to use a different color. Okay, to see where they cross, right? We've seen similar questions before. So the other function we're going to graph is 5 raised to the power of 1 minus x. I'm going to use green. 2 curves, right? So when will the curve cross? When will the curve cross? Somewhere, right? Between 0 and 1. Okay, excuse me. So this picture tells us there's a solution, but we don't know what is the solution. Okay, the precise answer is very difficult to identify from the picture, but we can confirm that there is a solution. Okay, there is a solution. And so we have to resort to algebraic method to solve it. Okay, so this is function perspective. And in most of the situations, they just go straight to the algebraic method. Okay, so if this is true, and most of the other method will be, I think one of the common methods we use here is just taking logarithm on both sides. You can choose to take common logarithm, you can take a natural logarithm. And I would take the natural logarithm on both sides. Okay, taking natural logarithm on both sides. And then we're going to use the power rule. Okay, the power rule, then we'll bring the x over to that power. And so ln7, that equals to 1 minus x. These two must be inside parentheses, so it's ln5. We must be careful that ln7 cannot be separated. This is one single number. ln5 is one single number. And as you see, we have x on both sides. We have x on both sides. And here we have a little 2, okay? To get rid of the fraction, we can multiply both sides by 2. Okay, so we're gonna write x times ln7 is equals to 2 times of 1 minus x times ln5. This step is not entirely necessary, but it helps because it gets rid of the denominators. You get rid of the denominators. Okay, and we like that. And we like that, okay? So we have multiplied by 2 on both sides. On both sides. Okay, and then we want to bring the terms with x together. We have x term on one side, and we also have x term on the other side. And here, I want to put a little note here, okay? Don't write x times ln7 in this way, ln7x. Don't write it this way because it is very confusing. Okay, it's very confusing. If you want to do it this way, you can do this way. Okay, you can keep it this way, or if you insist to put x afterwards, in the behind, you put a parentheses. Okay, so these are the do's, and this is the don'ts. Okay, so don't. Okay, don't write it this way, because if you write it this way, it will be regarded as ln on the product, natural log on the product. Okay, so don't do it this way. Okay, so this can be regarded as ln 7x. So they usually are considered the same. Okay, so this is the little note I wish to remind you. Okay, and next we have x on both sides. On the right-hand side, we have to open up the parentheses and distribute the 2 times, right? So you can bring the 2 inside the parentheses, right? So you can do that, okay? So you can just do little by little. I think most of the difficulties and mistakes we saw is the confusion of expression, So I'm doing slowly here. I will take the 2, multiply each term inside, and then I'm going to distribute ln 5 to each term. Okay, so the next step, I'm going to write 2 times ln 5, 2 times ln 5 minus 2x ln 5. So the x is in the middle, right? Because we don't want to put x behind. So this is a single number. That's easy to accept, but this is also a single number. We don't want to confuse it, but the x is here. So we're going to bring the x terms on the same side. Okay, so we're going to add the 2x times ln 5 on both sides. So this is what we get as a result. So this is gone. Okay, so we added 2x times ln 5 on both sides. Okay, so added 2x times ln 5 on both sides. Okay, I hope that's clear. All right, so now we can factor out the x. So x is factored out, right? And this term, x is factored out, we have ln 7. The other term, after x is factored out, we get 2 times ln 5. On the right-hand side is 2 times natural log 5. Now we're going to isolate x, dividing both sides by the number in front of x. Okay, so we divide both sides, okay, by the number in front of the x. So dividing both sides by it. But we can remove the parentheses, it would not be necessary, right? So in the end, x is equals to this number. And we are finished. We're finished. Okay. So now we finished the question, but if we look at the perspective, the function perspective, right? If we look at the function perspective, we have find the input such that the outputs of 2 functions are the same. So what will be that output, right? That's the question. What will be the output? So how high is this point? So at this point, you can plug in either one. Either one should give you the same output. Say I'm going to use G, okay? And I'm just going to find the output, right? So input, okay, the interpretation. When the input, right? And that's the output. When input x is equals to this piece, the output is g of x, right? And x is this value. So we're going to bring the x to the function like that. Okay, so if we are to simplify that, we certainly can simplify it. Okay, or just leave it there because this is not part of the requirement, right? So what I would do is that I'm going to plot the points. So this is the output. Okay, we'll come back to see if we can simplify it. Okay, so it looks very intimidating, right? So the point of intersection, right? So we have the output and the input. The input, of course, is the x, right? This piece, 1 minus x. So we put it here and we put a red dot. Does this show? Yes, it does. So that's the number. It's a one single number. And this is the input, okay? And you calculate ln 5 times 2 divided by ln 7 plus 2 times ln 5. Can you simplify this? I think it's going to be a little bit hard. It's going to be hard to simplify that, right? Anyway, it's going to be just a single number. So let's just not worry about it for this moment. And it just, you have the idea about it. You just have the idea about it. Okay, so this is how to solve equation, one of the equations in your homework. Okay, you can see it's a little bit more complicated than the simple exponential equations we did before. Okay, next we're going to do number 5. Okay, we're going to do number 5. This is example number 3. Okay, and this one, of course, is solve for x. Okay, solve for x. The equation we have is 2 to the power of 3x plus 1 is equals to 3 times of x minus 2. The function perspective actually are very similar to the one we just did, okay? That is that we have, you can look at the function perspective. Right, the function perspective we have is that we have a function f, right? And this function is 2 to the power 3x minus 1, right? And we're going to graph it. And we have another function g of x equals to 3 to the power x minus 2. So we're going to graph these two functions in one frame. Okay, let's see which one we graph first. It doesn't matter. We're going to get to them both. So this one is f. Okay, so we're going to choose the black color. And let's make some adjustment. Okay, we don't need to. So this is something like that. They're both positive. Okay, they're both positive. So that's 1. That's 1. Okay. And I'm making a little more adjustment so the axes are cleaner. Okay, the axes are cleaner. And I'm going to make it scoot over a little bit. Okay, so as it comes over. So this is the black color. This color is black. And this one, we're going to graph it in the same frame. I'm going to use a different color. Okay. And this color is going to be green. The green color curve, it looks like we need some more adjustment, right? Do they cross, right? It looks like they're crossing somewhere. They're crossing somewhere. And this curve obviously doesn't show it very well. So we need to do something about it. So let's maybe over here, I'm going to make this just like this. Okay, so this might be better. It looks like there might be meeting somewhere, but it's hard to tell. The software does have limitation. Okay, the software has limitation. So in this case, I'm going to make it like this. Is this better? it looks like in this direction, they're not going to meet. They're not going to meet. If they meet, it's going to meet it somewhere here, okay? So in order to make that C better, I'm going to just do something here. How about that? It looks like they're going to meet somewhere down below. They're going to meet somewhere down below. Okay, obviously it's very, very difficult to read that crossing. So we have to resort to algebraic method, right, to identify that point of intersection. Okay, so we're going to identify the input such that these two functions have the same output. Well, let's solve this equation, right? What do? We're going to use the same technique. We take natural logarithm. You can take a logarithm of any base, 10, 2, 3, any base you want, okay? So we bring down the power. We use 3x plus 1. That power is brought down. So we have ln2 equals to x minus 2 over here. That's ln3. Once again, we need to understand ln3, ln2. These are singular number. They cannot be separated. They have to be written together. It's a constant. And we have x's on both sides. So we have to, multiply out and then combining like terms, okay? So ln x times 3x, and that's gonna be 3x times ln2 plus ln2. That's the left-hand side. Right-hand side, we have x times ln3 minus 2 times ln3. And we're going to bring the x terms together. Okay, so subtracting these on both sides. So 3x ln2 subtracting x times ln3 and subtracting ln2 on both sides. So we have negative 2 ln3 minus ln2. On the left-hand side, okay, we can factor out the x. Okay, you can put it in front, you can put it in the back, doesn't matter. So you have 3 times ln2 minus ln3 equals to the right-hand side entirely is a negative. So that seemed to agree with what we observed, right? The point of meeting is going to be a negative x, right? The value of x is going to be negative. So now we're going to divide both sides by the parentheses. Okay, we're dividing the both sides by the parentheses. Dividing by the number in front of x. So this way we'll isolate the x. Okay, we isolate the x. You can remove the parentheses. Now x is solved and it is equals to this number. Okay, and that's the input. Okay, somewhere down there. Okay, and by this time the question is done. The question is already done. In most of the cases, when you encounter something like this, you're finished. You're finished. However, okay, so let me make some adjustment to the picture. I think starting from 0 will be better. Okay, so here, right? So we're still curious about where that point is, right? That point obviously is very, very close to 0. And so this is the input, and what will be the output when the two curves meet, right? So I'm going to plug in one of the functions, right? So when x equals to this value, I will plug in it. We're not going to simplify, okay? We just let the calculator does the work, okay? So the point of intersection of these two curves, the point of intersection will be the input, right? That's the input, and that's the output. That's the output. And there we go. We're going to put this point on the graph. I'm gonna put the point on the graph to see where we get it. Okay. I'm gonna put this point on the graph. It should have a little red dot, right? So I'm gonna put this point on the graph, show me the red dot. Ah, I think the software cannot manage, cannot do it. Okay, what are we gonna do? Let's see if it gave us a numerical value. Very, very small, right? Very, very, it's pretty small output. And the input is such, right? It's negative, nearly -3. So let's try these two numbers, okay? So this is approximately, okay, approximately the input, and that's the output. Let's see if it will plot the points for us. Okay, this is purely out of curiosity. You don't have to do this. Your work ends here, okay? Your work ends here, ends here, okay? So I'm gonna put this point on the graph. Obviously, it didn't make it last time. Oh, never mind. I think okay, so let me do this. Okay, wait. Yeah, what's going on? The software is not always, okay, we can make it work. Okay, worst come to worst, we can do it over. This one, these two, third one, oh, so we didn't delete that one. Okay, there we go. So let's see if I probably can put this point in, okay, because earlier I put the wrong things in place. Add point, and that's the red dot. There, it showed up, right? It showed up. So it's very, very close to 0, but didn't touch 0. It should not have touched 0, okay? So the curve it should be above. It just should be a little bit above. Okay, so let me see if that, yeah, you can see I lifted up a little bit. Okay, I lifted up. Actually, I'm gonna lift it up even more. And that's the point of intersection. There you go. This is the point of intersection, okay? So for this picture, I probably should have done that too. Okay, so it does have a point of intersection, right? So you just have to do the zooming. To solve this particular question, right? All you need to do is to do this part. You don't need to do the numerical part, forget about it. But just out of curiosity, right? To have a complete picture about what this is all about. And you can look at the value and you can, zoom in, and then you see, oh, the curves actually do cross. They cross it only once. And that's the point of intersection. That's the point of intersection. Okay, so that's the other question in homework number 13. So this is the homework guide to cover that piece. I actually see some repeats in that homework, so I'm going to just delete it. So without further ado, that's all for this lesson. That's all for this lesson. If you have any questions, please do not hesitate to reach out to me, and make sure you can do these. I mean, this piece, make sure you can do this piece, okay? And the other contents it will be best if you understand how to do these algebraically, and you also know the function perspective, okay, what it means, okay, very, very important, okay? So that part is called analytical geometry. It's gonna be really, really good for you. Okay. So that's all for this lesson. Thank you for watching. Until next time.